This is a video on solving rational equations. To solve a rational equation, the first thing you want to do is determine the LCD for all fractions that appear in the equation. So you're looking for the lowest common denominator for all fractions that appear. The second thing you want to do is multiply both sides of the equation by that LCD that you just found. And when I really say that, I mean multiply it to every term. So any term in the equation, regardless if it's a fraction or not, should be multiplied by the LCD. Alright, this is what clears out fractions and allows us to solve. Step 3, you want to distribute to remove parentheses, only if necessary. Sometimes you'll have to do this, sometimes you won't. And then step 4, you want to solve as normal for equations. Let's take a look at an example. So we want to solve x minus 3 over 5 minus 7 over 2 is equal to x minus 1 over 3. And our first step was to find an LCD, and in this case the LCD, right, of all fractions that appear. So I'm looking at the 5, the 2, and the 3. Alright, 5, 2, and 3, the smallest number they all can go into evenly, is 30. So the LCD here is 30. Now remember, we're doing this because we have a rational equation, meaning we have an equal sign here, and we have fractions that appear in the equation. Alright, so that's how you know you have a rational equation. That's what's telling you to find the LCD first. Once you found the LCD, now you want to multiply it to every term. So this is going to be 30 times x minus 3 over 5 minus, because that's a minus sign there, 30 times 7 halves is equal to 30 times x minus 1 over 3. And notice I'm using parentheses to separate it out. Once you multiply everything by 30, what you really want to do is you want to divide it out with the denominators to cancel out fractions. Alright, so you're trying to clear fractions here. And it should divide evenly with all your denominators since we found it based on it being an LCD. So 30 divided by 5 would leave me with a 6 out in front here. So I have 6 times x minus 3. Minus gets a minus sign. 30 divided by 2 gives me 15. So I have minus 15 times 7. And that's equal to 30 divided by 3, which gives us 10 here out in front. So it's 10 times x minus 1. And notice we cleared fractions here. That's what we were trying to do by finding the LCD and multiplying it to every term. You only can do this if you have an equation. You can't do it if it's just an expression. In other words, if there is no equal sign, this isn't the step you would follow. Once we're here, you want to solve as normal for equations. So we're going to distribute to remove parentheses. So 6 times x gives us 6x. 6 times a negative 3 makes us a minus 18. Minus 15 times 7 will be 105. And that's equal to distributing the 10 through. 10 times x gives us 10x. 10 times a negative 1 gives us negative 10. Alright, once we're here, you want to combine like terms and solve like normal. So we're going to have 6x, and then minus 18 minus a 105 will give a negative 123 is equal to, here we got 10x minus 10. And now you want to get all your variables on one side, all your numbers on the other side, just like you normally would to solve. So I'm going to subtract 6x here and subtract 6x here. So I'll be left with negative 123 is equal to 4x minus 10. And then to isolate the variable term, I'll add 10 to each side. So add 10, add 10. And I'll move this up here. And negative 123 plus 10 is negative 113. And that'll be equal to 4x, since our 10's cancel out. And then solve for x, divide by 4, divide by 4. And we get x is equal to a negative 113 over 4. If it doesn't reduce, which in this case it doesn't, you just leave it as is. Alright, it's okay to get a fraction as your answer, that's fine. So x is equal to negative 113 over 4. Let's take a look at another example. We want to solve the equation 6 minus 5 over x is equal to 13 over 4. Well, first you want to analyze that it's a rational equation. So it's got an equal sign and it's got fractions in it, so that tells you it's a rational equation. And you want to look for an LCD. In this case, you're looking for the LCD of all the fractions that appear. In this case, we only have 2 fractions, so the LCD between 4 and x is 4x. And now our next step is to multiply that LCD to every single term, whether it's a fraction or not. So even though 6 isn't a fraction, we still multiply it by the LCD. You have to do this in order to keep the equation balanced on both sides. If you don't multiply it to everything, or to every term, then your equation is not balanced and you're not doing a legal math operation. So we'll have 4x times 6 minus 4x times 5 over x is equal to 4x times 13 over 4. And once we're here, we're going to do exactly what we did last time. You're going to multiply. Once you're here, you're going to do exactly what we did last time. You're going to multiply the LCD to each term, and if it cancels the denominator, you're going to cancel it out. So in this case, 4x times 6, well, that gives us 24x. There is no fraction here to cancel with, so you just multiply them together just like you normally would. So 4x times 6 is just 24x. Minus, here the x's cancel, so you're left with just 4 times 5, so it'll be minus 20, is equal to, here the 4's are going to cancel, so you're left with x times 13, which is 13x. Alright, fractions are cleared now. That's what our goal was, clear fractions. Once you've done this, now you want variables on one side and your constants on the other. So I'm going to subtract 24x from each side here. Isolate my x's on the right side of the equation. These cancel. I have negative 20 is equal to 13x minus 24x is a negative 11x, and then we're going to divide by a negative 11 divided by negative 11. So this will be equal to, those cancel, we have x equals, a negative over negative makes it a positive, 20 over 11 doesn't reduce, so we're just going to keep it as 20 over 11. Again, it's okay to get fractions as your answer here. Let's take a look at one more. So we want to solve x plus 2 over 6x plus 11 over 3 is equal to x plus 4 over x. Again, we're looking at to see if we have a rational equation. It's an equation because it has an equal sign. It's rational because it has fractions in it. Your first step when you have a rational equation is to find an LCD. In this case, we're looking at all the denominators, right? For all terms that appear, we've got 6x, 3, and x. And actually, the LCD for this is going to be 6x. Looking at the numbers, 3 and 6, the smallest number they can both go into evenly is 6. And then looking at the variables x and x, the smallest variable they'll go into evenly is x. So the LCD is 6x, so I'm going to multiply every term by that. So it's going to be 6x times x plus 2 over 6x. Plus gets a plus sign, 6x times 11 over 3 is equal to 6x times x plus 4 over x. Make sure you're multiplying to every term. Right, once we've done this, we're going to cancel and multiply. So 6x and 6x, they cancel out exactly here to a 1. So you got 1 times x plus 2, and 1 times anything is just itself. So I'm just going to write this as x plus 2. Technically, we distributed the 1 through, but 1 times anything is just itself. Plus here, I've got 6x times 11 over 3. Well, the 6 and the 3 divide out. 6 divided by 3 gives you a 2, so you're left with 2x times 11, which gives you 22x. And that's equal to, on this side, the x's are going to cancel out, so you're left with 6 times x plus 4. And now we're going to simplify. On the left side here, I've got an x plus 22x, so it'll give me 23x plus 2 is equal to, here I got to distribute the 6 through, so I'm going to have 6x plus 24. Now we want variables to one side and our constants to the other, so I'm going to subtract 6x here and subtract 6x here, so I'm going to have 17x plus 2 is equal to, these cancel at 24, and then I'll subtract 2, get my x's isolated, I'll have 17x is equal to 22, and then solving for x, I'm going to divide by 17, divide by 17, and I get x is equal to 22 over 17, which doesn't reduce. And we've solved it. Here's an example for you to try on your own.